Hello everyone, welcome to Maths Vedika. So let us solve questions asked in class 10 CBSE examination 2026. So the first question is from trigonometry, and the question is if tan theta by 1 by tan theta is equal to 2, then we have to find the value of 1 by tan square theta plus tan square theta. So solution of question first. Tan theta plus 1 by tan theta is equal to 2. Then we have to find the value of tan square theta by 1 by tan square theta. So tan square theta plus 1 by tan square theta can be written as tan theta plus 1 by tan theta whole square minus 2. Okay, when we'll solve this, tan theta plus 1 by tan theta whole square minus 2 will left with tan square theta plus 1 by tan square theta. Okay, and we have tan theta plus 1 by tan theta is equal to 2, so we'll put the value 2 square minus 2. So 4 minus 2 will be equal to 2, hence the solution. Solution of question 2. So given, prove that root under 1 minus sin x 1 minus sin theta by root under 1 plus sin theta is equal to sec theta minus tan theta. So LHS root under 1 minus sin theta by root under 1 plus sin theta. So rationalizing the given value, multiplying the numerator and denominator by 1 minus root under 1 minus sin theta, 1 plus sin theta into root under 1 minus sin theta. So in numerator we'll have 1 minus sin theta whole square root under, and in denominator we'll have 1 plus sin theta into root under 1 plus sin theta into 1 minus sin theta. Okay, in numerator we'll left with 1 minus sin theta, and in denominator we'll have 1 minus root under 1 minus sin square theta. Okay, is equal to 1 minus sin theta by root under 1 minus sin square theta is equal to cos square theta, is equal to 1 minus sin theta by cos theta. Okay, is equal to 1 by cos theta minus sin theta by cos theta. 1 by cos theta will be written as sec theta minus sin theta by cos theta tan theta, which is RHS, hence proved. RHS is sec theta minus tan theta. Okay, now question number 3. Question 3 is, if alpha beta are the zeros of the quadratic polynomial px square plus qx plus r, then we have to find the value of alpha cube beta, beta cube alpha. Okay, so given quadratic polynomial is px square plus qx plus r. Okay, and alpha beta are zeros of the given polynomial. So we have to find the value of alpha cube beta plus beta cube alpha. Okay, so we know that sum of zeros will be equal to minus b by a, so here minus q by p. Okay, and multiplication of zeros, product of zeros is equal to c by a, so here we'll have r by p. Okay, alpha cube beta plus beta cube alpha can be written as, let us take alpha beta common, so we'll have alpha square plus beta square. Okay, alpha square plus beta square will be written as alpha plus beta whole square minus 2 alpha beta. Okay, and we have value of alpha beta and alpha plus beta, so we'll put the value alpha into beta. Alpha into beta is equal to r by p, so r by p into alpha plus beta is equal to minus q by p whole square minus 2 alpha beta is r by p. Okay, so we'll have r by p into q square by p square minus 2r by p. Okay, r by p into LCM will be p square, this will be q square minus 2rp. Okay, so we'll have r into q square minus 2rp divided by p cube. So this is the answer. This is the value of alpha cube beta plus beta cube alpha. Okay, I hope you understood the solution. So we'll meet in next video with some other question. Thank you for watching the video. Thank you.